welcome everyone. Thank you for hosting me today. My name is Martin Beracochea. I am the production project leader at MGnify. So today I want to talk about how we are trying to run our production workflows, and how we are trying to orchestrate the workflows that run to make a more sustainable service. Mike, closer. Now? It goes there. Now, can you hear me? All right, thank you. Should I just click here? So I should first start with what is MGnify. MGnify is Humboldt's EBI metagenomics resource. We basically run a service for we run a free platform for the analysis and archiving of metagenomic sequencing data. We basically run a set of standardized and community best practices pipelines on data, and we make all those data products that we produce available to the community through our websites and API. One of the things that makes us slightly unique is that we are really tightly coupled with the European Nucleotide Archive. So as soon as a piece of data becomes available on the archive, we can analyze that. In order to try to understand some of the infrastructure challenges that we face, I think it's useful to see where we are in this particular data ecosystem. So as I was saying, we sit between researchers and ENA, basically. So basically, as soon as researchers deposit the metagenomic-related data on ENA, that data may be sourced from a wide range of biomes, which they take. We then take that data and we run a bunch of different analyses on them. You can see some of these different data products that we produce on that relatively busy schema. So we run taxonomic annotation on the data. We run functional annotation on the data. We also collect proteins in there. So all of those data products then become available to our API, and so it's important to know that it's sort of to close the gap. Some of those data products also flow back into ENA. For example, the assembled metagenomes, we also push them back to ENA. And again, also the metagenome assembled genomes that we produce also flow back into ENA. So we are also backfilling some of that data to ENA. So far, we have analyzed over 600,000 data sets from more than 5,000 studies. Our protein DB has 2.5 billion proteins at the moment, and we have a bunch of assemblies that we need to retrofit. So that number is going to go up in the next few months. And we recently passed 500,000 genomes in our MGnify genome resource. So we produce a bunch of data. So what is the MGnify mission? What is our ambition? We are set to try to analyze all of the microbiome-related data in ENA. That is a very ambitious goal, but we are trying to achieve that. So far, we have identified three main challenges in trying to achieve that. How we are going to scale our resources to try to do that, given that the sequencing data keeps growing, the number of deposit metagenomics data sets on ENA keeps growing over time, and I don't think that's going to stop anytime soon. Another key aspect of the data is how we are going to track the metadata across all of our pipelines. So we produce incremental data products, so we need to keep the provenance of that data. And we also need to make sure that that metadata is also available for the end users. And another of these challenges is how we are going to run a reliable service with outfunded models. So I'm going to go over these challenges one by one. First of all, this is no shock to anyone here, but the data sequencing has become much more accessible over the past few years. It become much cheaper, so anyone is sequencing metagenomes now. And those two charts in there try to represent some of that. The one on your right, is it right? Yeah. Is an example of that. Is a number in blue is the number of amplicon data sets on ENA over time. And as you can see, it roughly is like a tenfold increase over the past 5 years or so. The orange line shows the number of analysis that we produce for Amplicon data. So yeah, we are trying really hard to keep up with that. Another kind of data set that we analyze and has been also growing over time is the number of metagenomics runs, and you can see that on your left chart. Again, the blue line represents the number of metagenomics runs on ENA over time. Again, it's like the tendency is for that to keep growing, and you can see in the orange line the number of analyses that we have on our website. So again, we are trying to keep up with that. As I was saying, the second challenge that we have is how we are going to track the metadata across our file system. So we do run a bunch of different pipelines for different data products, and some of them are incrementally produced. So, and these two diagrams here show how that metadata need to move across our systems. You have to think for any given sample, we may run gene prediction tools. We also run annotation tools. We run taxonomical annotation tools. We also assemble some of that data, producing another data artifact. We also take those assemblies and produce meta-assemble genomes from that. So we need to make sure that for any given sample, we are able to trace back where it came from and how that data was actually transformed during that process. Not only that, but we need to make sure that also that metadata is also available to end users through different APIs and endpoints. The third challenge that we have is how we can maintain the service running with our project-based funding. So we have 16 odd team members in our team. You can see the pictures of that lovely people there. But many of them work on funding agents. We are funded by different grants. We have some Envoy core funding. We have UKAI funding. But we also participate in many different EU-based projects. This is a really good thing. I'm not complaining about that. This also not just because it allows us to work on MGnify, but also because it allows us to communicate with different communities. Every single community do metagenomics in their own way, and every single community has their own peculiarities that we need to attend to. So this actually gives us the opportunity to cross-check that the kind of things that we are doing for the service actually are suitable for them. So that's really important. Nevertheless, this does create a problem. So we have people working for different projects. Each different project has its own deliverables, own reporting commitments that we need to do, which more often than not pulls people away from the core service. So it creates a bit of a coordination issue there. Oops. So I'm going to go over some of the things that we're trying to do to try to address these challenges. I am a technical person, so most of my views of the world go through that lenses. So this is probably going to be more under the nitty-gritty details of the technical stuff. But I think it's important to understand how MGnify has evolved over time. So we've been around since 2012. I think, and at that time, the number of data sets was relatively slow in metagenomics. So basically, the service ran on top of a set of Python scripts that were like coordinated with some bash. It was a relatively complex code base. It was really hard to maintain. So every time you try to fix or add new features, you end up bringing something on the other end. So in 2019, we decided to migrate our stack into a more like formal definition of a workflow. We decided to move to the common workflow language, which has been highlighted in the last presentation. That gave us like a good foundation. So now our pipelines were like formally described. We knew which steps were actually being run in a sensible way. We were adopting some of the community standards, so it allowed us to use some of the stuff that other people were doing. So all the good stuff. As we move along this timeline, also it's important to know that we were heavily investing in building the software skills in the team. So not just moving technology, but also trying to make sure that we were building software in a industry standard way. So we adopting all of these kind of things that you do in the software industry, like having CI, CD, that sort of thing. Last year, the CDB pipeline works just fine for the time being, but last year we decided to move to Nextflow. That was partially because EBI as a whole was adopting Nextflow as a supported workflow management system, but also Nextflow had a few features that we would like to use. At that point, we also contacted the NF Core community. There was a talk about NF Core, I think, on Monday. NF Core is just a community of developers of pipelines using Nextflow, and they provide a bunch of building blocks that you can use to build your own pipeline. So again, moving towards like community-based solutions. Nextflow worked well for us. We were happy Nextflow users, so our pipelines were like getting more complex. We were like tackling bigger issues and bigger data sets. But still, we needed a way of orchestrating all of those pipelines. So we decided to build our own orchestration system using Prefect there. Prefect is a Python-based orchestration tool. So we built that to run our pipelines. Again, as I was saying, this process, again, us moving from more of like non-so-professional software developer experience, more into, okay, adopting all of the industry standards, trying to have like a continuous integration in everything that we do, unit tests for everything that we did, integration tests whenever it was possible. So based on this new way of doing things within the team, a new tech stack, this actually built the foundation for where we are, and it helped us tackle some of the challenges that was going before. In terms of scaling, and scaling in terms not just of resources, in terms of compute, but also people's time. Having automation massively free people's time. So now people can actually do more interesting things instead of like babysitting processes and workflows. The orchestration with Nextflow and Prefect actually was a really good thing, because now we can burst some of the compute into the cloud. I was just doing that the other day. We had a deadline for producing a large number of assemblies. And because of this new system, I was able to burst some of that compute to Google Cloud. So that was nice. In terms of metadata, having community-based formal description of our workflow was a step in the right direction. The workflow community is building a bunch of tooling around that. Recently, I think last year or like this year, there's a new plugin for Nextflow was released, one that gives you arrow crates as a way like using the workflow run profile, so you can get like a arrow crate for your pipeline execution. Those kind of things is a step in the right direction. In terms of the orchestration system and keeping tracking our different data products under metadata across our system. Basically, we have a system that is backed by a relational DB that keeps track of everything as it moves along our system. And then in terms of how we deliver the service, again, using community standards massively accelerate how you develop things. But yes, as Mario was saying, don't be afraid of adapting those standards if you need to. That is really important. And this is for no one's surprise. We are using containers for everything now. So all of our pipelines use containers. We don't manage software outside of containers. That's massively helped us. It made it super easy to run things on the cloud, for example. Quickly to touch base on some of the things that we were doing. I think, in my opinion, the biggest constraint that we're going to have is the compute resources to tackle the amount of data that we are seeing. And I brought back the chart with the number of metagenomics runs on ENA there. So we are starting to explore with other institutions, try how we can actually federate some of that compute, because we do have collaborators and other institutions running metagenomics pipelines, so we can bring that together. So, and actually just having a concrete example there. So some folks we work with in University of Freiburg, in the Galaxy Europe team, they ported one of our pipelines into the Galaxy. So now it's possible to run exactly the same pipeline in a different workflow system, and the results will be exactly the same. So I think that's one way of trying to start federating some of the compute. We have also been involved in some of the past biohackathons from Elixir, try to build on arrow trace and that sort of like schema-based kind of thing. And that's basically it. I just want to thanks my team. We finished our team lead, which is around. There's a few more team members around. So I just want to say also thank you to our funding agencies that make all of this work possible. And I have one more slide. If you want to learn more how MGnify, the nitty-gritty details of how MGnify is actually built, there's 2 more talks from our colleagues later today in the microbiome section. Just go check them out. Tanya is going to talk about the MGnify genome resource, and right after that, Johanna is going to talk about tools she's building to try to cluster millions of genomes. So thank you for your time.
Thank you very much, Martin. I have no idea why we turned your lights off.
I don't know, just want me to leave, that's fine.
We'll see you. Are there any questions from the audience for Martin? If I can lead in, so you had experience of a CWL pipeline, Nextflow pipeline, and now
Prefect.
Galaxy pipeline.
Yeah.
Is it getting easier every time?
It is getting easier. I think in my experience, so I come from the software industry and I worked there for a long time. I think what the community is doing is taking all the lessons of the software industry, just learn over time all from those mistakes and building smaller components that you can share across pipelines. So one of the benefits of using sort of like the NF Core tooling, for example, is that you can share the same components and you can share those across pipelines. Not only by copy and pasting that, but you can actually, you have command line tools that you can use to do that. So you can automate a bunch of that. So yeah, it's becoming easier in my experience.
And similar in bursting out to the cloud, presumably your on-premise and your public cloud are different from each other?
I mean, so that is another sort of like benefit of how we build things. So Nextflow made it super easy to run the same pipelines into the cloud. They separated the thing quite nicely. So if you're going to run the same pipeline in a different infrastructure, for example, the cloud, it's basically a new config file that you need to set up. Basically saying, okay, this is the cloud provider I'm going to use. This is the account. These are the settings and so on. So it becomes quite easy to do, and it takes care of moving data around.
Hi, I'm from NIID. I have great presentation. I have a question related to AMR. Are you tracking, because you mentioned that there's a genome assembly in your pipeline, but for us, like our institution, well, of course, care about the drug resistance, any AMRG, mobile elements, or anything that you're tracking on your end, or is there any databases use this data to fed and, anything?
If I understand your question correctly, yes.
So AMR?
Yeah. We run some tools to annotate those in our pipeline, so they are part of our data products. We also have a mobilome annotation pipeline for metagenomics, which is also part of the suite of analysis that we have.
Yes.
So we do care about those things.
So if you detect something, is it show or fed in another database? Like, will it be like tracked by different portal or?
No, not at the moment. We do track some of that internally, and we made it available on our website. We don't feed anything to other resources.
Thank you.
That's right.
We have time for one more question.
Great talk. I just was wondering about the way you orchestrate. So Prefect?
Prefect, yeah.
That's a way of orchestrating multiple Nextflow pipelines to do like one big job. Is that
Yeah, we sort of do that. So we use Prefect because Nextflow is not really suitable when you're talking with a relational DB, for example. It's not really suitable for that. So all of the metadata and like tracking is being done with that. Anything that requires calling APIs or like calling a DB or not, and then it actually runs. Okay, I need to run this for this to generate this data product. I need to run this pipeline first, and then it keeps track of the metadata. And the next step is running the second pipeline. And that's the sort of thing that we use Prefect for.
Thank you. And our next speaker is